Alright guys, now let's continue with differentiation for trigonometric functions. Now we know that there are 6 trigonometric functions. We have the sine, we have the cos, we have the tan, we have the sec, we have the cosec, and we have the cot. Now let's start with sine. Let's say y is a function of sine x. If y is equal to sine x, now how do we find the derivative coefficient of this differentiation for trigonometric function? Now using first principle, if there is an increment in x, there will be what? An increment in what? In y. If y receives an increment del y and x receives an increment del x, so here del y is equal to sine x plus del x minus y, which is what? Sine x. Now remember from first principle, divide all through by del x, divide all through by what? Del x. Now if you watch my video on trigonometry, you remember that sine a minus sine b is the same thing as 2 cos a plus b all over 2 sine a minus b all over 2. Now that implies the rate of change is equal to, this is sine, this is a and this is b. So sine a minus sine b is the same thing as 2 cos a. The a is x plus del x and the b is what? X all over 2. Now sine a x plus del x and the b is what? Minus x. Then all over 2, then everything over what? Over del x. So that is the rate of change is equal to 2 cos, this is x plus x is 2x. So 2x over 2 is what? Is x. Then plus del x all over 2. Then sine x minus x 0, del x all over 2. Then all over del x. So del x, del y del x, that's the rate of change. If we transfer the numerical factor 2 to the right hand side, we can still write this as 2 cos x plus del x all over 2, then sine del x all over 2 all over del x. Now look at this 2 here, which is the numerical factor 2. If we transfer this numerical factor 2 to the denominator here at the right hand side, you see the same thing as having it as cos x plus del x all over 2, then sine del x all over 2 all over del x all over 2. If we transfer this to the denominator, it's the same thing as taking it here, that's what? 2 cos. Now remember the limit at which del x, del y del x tends to 0 is what? Dy dx. And the limit at which sine del x all over 2 all over del x all over 2 to which del x tends to 0 is 1. So if this is 1, so del y del x is what? Dy dx, which is equal to cos x, and del x all over 2 tends to what? Is 0, because del x tends to 0, that's what? 0. So the answer is what? Cos x. That implies that if y is equal to sine x, then dy dx is what? Is cos x. Now the second one, let's go for cos x. The cos x, if y is equal to cos x, now first principle, y receives an increment del y and x also receives an increment del x. So that gives del y as cos x plus del x minus cos x. Now also from trigonometry, cos a minus cos b is equal to minus 2 sine a plus b all over 2 cos a plus b all over 2. So sine a plus b all over 2. Now, divide all through by del x all through by del x. So that means the rate of change, this is a and this is b, that gives minus 2 sine a plus b, that's x plus del x plus x all over 2, then sine x plus del x minus x all over 2 over del x. So the rate of change is equal to minus 2 sine x plus x, 2x all over 2 is x, then plus del x all over 2 sine x minus x del x all over 2 over del x. We can write as minus 2 sine x plus del x all over 2 sine del x all over 2 over del x. Now look at this numerical factor 2. We can also take it to the what? Denominator here. So that's derive del x is minus sine x plus del x all over 2 sine del x all over 2 del x all over 2. So we take the limit at which del x tends to 0. The limiting value gives dy dx, and the limit of sine del x all over 2, the limiting value at which del x tends to 0 as 1. So that gives dy dx as minus sine x plus this del x tends to what? 0 over 2 tends to 0, that's 0, and this is what? This is 1. So the answer is what? Minus sine x. So if we are to differentiate sine, we get cos x, and cos, this is the function, this is the derivative coefficient. So here we should get minus, we get minus sine x. Now what about the others? Now look at number 3 now. That's if y is equal to tan x. Now tan x, remember, is the same thing as sin x over cos x. So y is sin x all over cos x. Now a function divided by another function. Now using quotient rule. Now if I use quotient rule, remember from quotient rule, dy dx is v du dx minus u dv dx all over v squared. Your choice of v and u matters. This is your u and this is your what? Your v. Now that means dy dx is equal to v, that's cos x, du dx, differentiate sin x, that gives what? Cos x, we've done that already, minus u, which is sin x. Now differentiate v, cos x, that's what? Minus sin x. So all over v squared, that's cos square x. That's cos x times cos x is what? Cos square x. So that gives cos square x plus sin square x all over cos square x. Now remember from trigonometric identity, cos square x plus sin square x is what? Is 1. So that's 1 over what? Cos square x. And 1 over cos x is what? Sec x. So 1 over cos square x is what? Sec square x. So dy dx of this is what? Sec square x. Now the next one is y is equal to what? Sec x. Now remember here I said 1 over cos x is sec x. So sec x is as what? 1 over cos x. Now here to using quotient rule. 1 over cos x. This is my u, this is my what? My v. So dy dx is v du dx minus u dv dx all over v squared. So v is cos x, du dx, this is a constant. The rate of change of a constant, you can't find that. That's 0, 0 minus u, 1. The v dx, differentiate cos x, that's what? Minus sin x. That's minus sin x. So over v squared, that's cos square x. So the answer is 0 plus sin x all over cos square x, which is sin x all over cos square x. Now this sin x all over cos square x is the same thing as sin x over cos square x, which is what? Sec square x. But we can write this as sin x all over cos x times cos x, which is sin x over cos x times 1 over cos x. So that means the derivative coefficient of sec x, instead of writing it as sin x sec square x, you can write it as sin x over cos x is what? Tan x. 1 over cos x is what? Sec x. So this is tan x sec x. Now the next one is cosec x. Cosec x. Now cosec x is the same thing as 1 over sin x. So if y is equal to cosec x, is the same thing as 1 over what? Sin x. Quotient rule, u and v. So dy dx is v du dx minus u dv dx, then over what? Over v squared. So this is your v. Your v is sin x. Differentiate u 0 minus u 1. Dv dx, differentiate this as what? Cos x all over sin square x. So the answer is minus cos x all over sec square x all over sin square x. Now remember 1 over sin square x is what? Cos square x. So we can write it as minus cos x cosec square x. But instead of writing it like this, we can still write it as minus cos x all over sin x times 1 over what? Sin x. Now sin over cos is tan, but cos over sin is cot. So that's what? Minus cot x. This is minus cot x. The 1 over sin x is what? Cosec x. Minus cot x cosec x. That's minus cot x cosec x. Now the last one, which is cot x. The last one, which is cot x. If y, number 6, if y is equal to cot x. Now remember I said that cos over sin is cot. So yeah, cot is the same as what? Cos x all over sin x. This is u, this is v. Quotient rule, dy dx is v du dx minus u dv dx all over v squared. So dy dx, the first derivative coefficient of the function cot x, v is sin x. So the u dx, differentiate u with respect to x, that's what? Minus sin x. Minus u is cos x. Differentiate v with respect to x, that's what? Cos x over v squared sin square x. That gives minus sin square x minus cos square x all over sin square x. That's dy dx. Now this is negative factor, this is negative factor. You can still be written as negative of sin square x into bracket plus cos square x over what? over sine square x. So from here, sine square x plus cos square x is 1. That's 1 over sine square x. And 1 over sine x is cosec x. So 1 over sine square x is what? Cosec square x. So there's a negative factor here. That's minus cosec minus cosec square x. So the derivative coefficient of cos x is what? Minus cosec square x. So I can then write in tabular form the 6 trigonometric functions and their derivative coefficients. So if you differentiate sine x, you get cos x. If you differentiate cos x, you get minus sine x. And if you differentiate tan x, you get sec square x. And if you differentiate sec x, you get tan x sec x. And if you differentiate cosec x, you get minus cot x cosec x. And if you differentiate cot x, you get minus cosec square x. Now watch out for the next series under calculus. Thank you for watching.